Next up, David Minarsch from Olas, Valory. We met back at Stanford University, the first open source AI summit. I loved his presentation. I had to bring him back. So let's see if he has any updates from his previous presentation. Let's give a big round of applause for David.
Hey everyone, yeah, definitely some new content. Yeah, I'm here to talk about a topic which leads nicely on from my previous speaker. I'll be talking about multi-agent systems. Basically, how can we coordinate swarms of many agents in the context of the Olas protocol, and how that gives rise to agent economies. Also getting used to this delay. But let's first quickly introduce myself. I'm co-founder and CEO of Valory, which is a labs and core contributor to Olas, where I'm also a founding member. And in previous times, I did a PhD in economics. I've been building multi-agent systems for like 5 years now. And really, in a way, that's our mission. We want to, very aligned with Ilya, give people agents which they can fully own, either as individuals or as a group. I'll also quickly say something on Olas. Basically, everything I talk about draws from actual production insights. So Olas has been deployed on 8 chains. The most active one we're currently on is Gnosis, where Olas agents do more than 20% of all safe transactions there. So far, so safe as this smart account. So let's get into it. I will be talking about a couple of things today. First, I will motivate multi-agent systems and why they're all we need. I'll then be able to also quickly justify why actually crypto and AI isn't just something to launch a token in, but actually has real utility. Then we'll talk about these open multi-agent systems and how we can also call them AI agent economies. I'll give you a concrete example, and then we'll look at how you can use the Olas protocol to basically build more of them with some examples of what you could be building. Now, all of this is sort of motivated by like some, I think, bigger like trends which we're seeing when we look at like the developments in AI. There's these kind of crossroads, everyone has a different meme. I have this very bad design, which I created myself, but basically, one future involves like us humans being sort of surrounded by these AGIs one days and ASIs one days that basically control us, or which are controlled by some humans, which we don't like. The other future is the one which we like, which is these systems actually enable us, and we can actually own them, fundamentally. Like, we want a future where every one of us can have one or multiple user-owned agents that do the things which we want, which might be different from what you want, right? Like, basically maintain an open society of humans and agents. So how do we get there? Well, I think I won't have time to motivate everything with data here. I'll just basically tell you how it is in my mind, and you can come challenge me later. Basically, multi-agent systems are all we need. Because firstly, if you think about scalability, ultimately, any monolithic system runs into like challenges around distribution of problem solving and parallelization. Multi-agent systems give you this for free by design. Actually, if you think about all the big distributed applications, they're of this nature anyway. Robustness often comes from redundancy. So in a human economy, we don't just rely on one provider of one good. We have like competing providers that gives robustness. If one supply chain breaks down, another one is available. Similarly with agents, fault tolerance arises as a result. Further point is that what we see in human economies as well, we'll likely see in agent economies, is that when you specialize, you get these economies of scale. Even if your model or your agent architecture or your agent plus model architecture can, in theory, do everything, in practice, it will be deployed where it's most useful, like at the margin. And so this, again, leads to specialization. Then if you think about how systems compose, systems that are monolithically composed have like real limits at the system design level. If you think about open systems which compose, they are clearly much more scalable. That's why one of the reasons why the Soviet Union didn't work out and why capitalism did actually work out. Then if we look at decentralization, we have like this inherently, I kind of referenced this before, and it also gives you all this kind of ability to adapt, have competitions on all sorts of layers and flexibility. And then finally, if you go sort of more in the architecture level of the models, obviously using multiple models, there's already papers and like, proven basically insights that you get like better results by using the diversity and collective intelligence of multiple rather than single models. Now, if that is so, then also crypto and AI is kind of implicitly motivated because suddenly you really need like a substrate for coordination, and I would argue that open permissionless crypto platforms are the natural substrate for that, as well as for collaboration. Whilst we can imagine that some agents will actually use Stripe to make payments, and in some cases that will actually be the natural and faster way to do it, at scale that doesn't work. And I'm with Ilya that like crypto platforms will be the natural place, and obviously there's very concrete examples like not requiring KYC and so on. We had this piece of ownership before, right? If ultimately we are in a world where we're all paying a tax to the state and to OpenAI or Anthropic to get anything done, that doesn't seem like a very defensible, like a very stable future. Whereas ultimately users, and that can be companies, that can be humans, that can be other AI agents, will want to take ownership of as much of their agents and AI as they can. You have the topic of platform risk. Again here, if we imagine like some sort of hub offered by Google or Microsoft or whatever, where all the agents communicate via, well, that might be like in some use cases the case, right? If we think about search or discovery or something, it's very unlikely that the global economy will run via a single like hub offered by a centralized platform. But like an Ethereum with 1,000 rollups on top and 1,000 further rollups on top of those rollups, or other chains like this, that becomes more credible. And then the last piece in this lengthy introductory piece is like around composability. There's the composability where Stripe offers a fantastic API, which is definitely better than 99.9% of APIs offered in crypto in terms of like the developer experience. And so yes, that kind of onboarding flow is there, but then that is the API they offer, right? Whereas in a crypto platform, you might have a set of smart contracts, a bit harder to get started, but the composability which can be done on top is sort of less constrained by its original designer, more open. So let's take these as given and go into then the rest of the conversation, which is I'll focus on the kind of multi-agent systems which are more competitive. So my predecessor, he introduced this notion of or concept, and he was talking mostly about the cooperative ones. So there, a multi-agent system is sort of inside an application, and you have these multiple agents kind of collaborating to get some stuff done for you. Here I'm mostly talking about like the multi-agent systems where different entities own agents which do things on their behalf, compete with each other. Basically, it starts looking very much like a human economy, right? Like you have different people owning different agents, doing different things, supplying services to each other, and so forth and so on. So these agents need to communicate with each other and transact with each other, where, again, we have like interesting overlap with crypto, as already discussed, but they also need each other. So, an agent tends to then specialize rather than doing it all. And that becomes very interesting because now you have like all these agent dependencies, supply chains of agents, basically the final product will be the composition of all these kind of outputs. And this, again, like this is basically how economies work, right? So it'd be kind of surprising if in the AI context, once a lot of like our economic activity gets sort of outsourced to agents, like software agents, that will fundamentally be different. So now I want to briefly give you like a concrete example of what's live. So a lot of the transactions which I mentioned earlier actually come from a concrete use case of such a nature, an agent economy. So there's 4 different types of agents, of which there exist many copies. They collectively form like this AI-based prediction market, or the emergent outcome is that. So basically the agents interact. Some of them trade in on markets, some of them provide liquidity, others purely do research, which they sell on to other agents. This is live on Gnosis, and there's various partners involved, including Nevermind, who sits over there. And what's interesting here is that this kind of validates a lot of the points I made earlier around the specialization. So we found when this system scaled, and we were kind of working on those, that was quite interesting. Here's a bunch of data. I'm going to quickly skip it, but basically it's an open system. Anyone can contribute. There's different people running these agents. There's different like leaderboards you can go to see how the performance of these different subsystems is. You can just look at the data. Don't have to trust me. Now the big question is, okay, like there's this kind of proof of concept. We have like these agents live. They're forming an agent economy. We think that's where it's going, but still, like one key thing is how, like practically, you know, as an outsider, like how do I get more of this? But also, like as a doer, like how do I get more of this, right? And that comes down to coordination. And so we thought a lot about this, and basically decided to create like what we call loosely a staking protocol, but it's a bit more than that. Basically an engine to generate more of those autonomous agent economies. And we've developed this now. It's currently in the stages of being deployed. It'll be live on all the chains on which we are and all the chains we're going to. We call it proof of active agent. And basically what it is a mechanism to reward active agent contributions in these specific agent economies. Now, let me walk you through this a bit. So the first thing is that at the very top, there's an emission system. So you have the Olas DAO, basically guide emissions. You can think of it like Gauge's 2 different staking economies. That's vote-based. And then on those staking economies, we have basically each economy represented by a contract, smart contract. That smart contract lives on the respective target chain or chains. And this is now a very complicated system diagram. You don't have to fully comprehend it. The key thing is you have this contract. Let's say in predict, it'll be on Gnosis. The contract embeds certain KPIs. As the agents work into their economy, they sort of magically fulfill these KPIs if they're correctly designed. And then they unlock their rewards. If they don't, then they don't get their rewards. And that's basically how the staking works here. And then there's the whole kind of system diagram. Now, if, let's say, you have an idea, or we are currently working on with partners on launching new staking economies, then this is sort of how the process works. So you have, at the top of it, you define some goals, right? So in predict, the goals are that there's a certain number of markets which are being traded upon by a certain volume, and that the markets have a certain liquidity, so you can embed these things in the contract. You then launch this contract. Someone, either yourself or you incentivize someone else, builds these agents which target this, or this might just arise naturally because incentives are there. You have the operators then run these agents, and so the results come about. So when I'm talking about agents here, most of the agents we currently focus on in Olas are really like these sort of workers which are in the background, right? So these are not like something where we want the human to sit and do it themselves. The whole idea is to build like quick flywheels where autonomous software does valuable work on your behalf rather than you sitting there. There's these other products which we just heard about where you kind of leverage these in your interactions with crypto directly. Now, if any of you ever studied any economics, then just this is the slide for you. Basically, what we're doing is like we're productizing this concept of mechanism design. So the agents are playing a game game theory basically. They're playing a game where there's certain objectives they want to hit, and the smart contract basically implements this social choice function, as it's called, to basically force a certain equilibrium. So what Olas staking then as a whole does, it sort of creates this machine for having more and more of these staking economies which achieve certain outcomes on certain chains for certain groups. Now, a nice side product arises. So obviously you want, the whole thing has to make sense. So you want these staking economies to actually create some end user benefits and predict the prediction markets. But actually I think one of the hidden issues with crypto and AI is, and I was actually asking this question earlier to Ilya, but he skipped it. So still very curious on the answer there. I'll quickly pose it. I think one issue is that generally crypto tends to be very open, and what results is that a lot of the data ends up open as well. But that means that any kind of centralized model trainer will get access to that data plus all the private data they already have. So they're by definition always ahead in terms of when it comes to the data. And that will ultimately suck, because then we already know that for a given size of a model, if you have better data, your model is going to be better. So I think a big question, in Olas, but also more generally, is, okay, you have use cases where you're serving the end user, but you're also generating new data. And the interesting thing with these autonomous agent economies is you're doing this at a scale which is much, much bigger than with humans, right? If you have humans in the loop, obviously, they'll interact with a product a couple times. These agents do it continuously, several thousand times a day. And so we're generating a ton of data, which some of it is very synthetic in the sense that it gets generated by effectively models interacting with each other. It's highly structured, and you can actually feed that back in the training process. But if all this data is public, well, then basically there is no unique edge over time. So I think this is an interesting problem. If anyone has a solution to it, come talk to me. So, yep, I'm basically done. Basically, I think the way to solve this problem, this horrific graphic, is basically to lean into multi-agent systems. I think this will, to a degree, happen naturally. That basically, as I argued before, there's a lot of forcing functions which mean that it's quite naturally going to be the case that we have AS systems interact with each other and supply services to each other. But I think we can also proactively do things by basically building applications today which create these kind of flywheels, and then figure out how we can build open, user-owned agentic infrastructure. So if you're either interested in a use case or in contributing to this flywheel, then please come talk to us. More generally, the way I think about sort of what agents should be doing is really three big things. Ultimately, what do we care about? Health, wealth, well-being. So you want agents which you can own, which actually help you being healthier, have a better time with friends and family, and make money. And so there's a lot of agent economies we can be building today. Some of them will initially look like simulations. So there's, for instance, this agent hospital paper I came across where a number of researchers basically built doctors and nurses as agents and had them interact in a simulacra. You could build this as an agent economy. What's interesting about this is that if you imagine the researcher's problem here is they have a certain budget, and then that budget ends, and then they have certain results. In this case, actually, they're doing better than GPT-4. Well, if you run this with crypto incentives and a data flywheel which makes sense, we can run this forever and actually bootstrap ourselves towards fundamentally good agents which are kind of community or DAO owned. You can then extend this to researcher agents where we have an Harvard of agents, an open source Sora, and so on. So yeah, please come join me on this journey. And again, also shout out to Erica for putting together this great product.